In this video, we're going to review some exponent rules that you have learned previously in Algebra 1. We're going to review the product rule, the quotient rule, and the power rule. So let's take a look at this first question. It's asking us which expression represents this product in simplest form. So for something like this, we just want to look at the two monomial expressions and think about what we are able to multiply together. So we have two numerical coefficients of 3 and 4. If I multiply them together, I'm going to get a product of 12. Then I look at my x's. I have x squared times x to the first. So we have to think about, well, what is the product rule? The product rule is a property of exponents that tells us if we have common bases, let's say bases of a, in order to multiply them, we would add their powers. So keep the base, add the powers. So for something like x squared times x, we should get x to the third, since 2 plus 1 gives me 3. And then if I use the product rule for my factors of y, I should end up with y to the sixth, since y to the fourth times y to the second would end up with the addition of the powers of 4 plus 2. So we get 12x to the third, y to the sixth, choice 4. Now let's take a look at something like number 2 here. Which expression is equivalent to 3x squared quantity raised to the third? So the first way you could approach this problem is just to recognize that this exponent of 3 here means I'm taking this 3x squared and I'm multiplying it out times itself 3 times. And if we use this approach, we're going to end up using the product rule again. And even with the 3, I could use the product rule. Since I have all common bases of 3, this is the same as 3 to the third, since 1 plus 1 plus 1 is 3. And for x squared times x squared times x squared, I should get x to the sixth. 2 plus 2 plus 2 is 6. Now, because I know 3 to the third, that's a numerical value, I can simplify that to 27, x to the sixth. So that's one way to approach this problem and to get answer choice 4. The other way, I'm just going to rewrite the problem here, would be to use the power rule. Now, the power rule tells us if we have a power raised to a power, so in this case, we're saying, hold on one second, let me just write it in more general terms, and then we'll come back to that problem. So let's say I had a to the m power now being raised to the n power. Power to a power says I can multiply those powers. So I can take the power of m and the power of n and multiply, and their product would be my new power. So if I look at this problem here, I have 3 being raised to the first power, x being raised to the second, and then everything now is being raised to the third. So let's take the original power of 1 for 3 and multiply it by this outside power of 3 to get 3 to the third. Let's take this original power for x of 2 and multiply it with the outside power of 3, and that will get me my x to the sixth, and then again, simplify the 3 to the third to give us a 27. So the power rule says when you have a power raised to another power, you multiply those powers. And then in something like number 3, we end up looking at, again, a couple of options here, but we could start out with the product rule. We have the product rule happening in our numerator. So let's start with that. So we have 2 times 8 would be 16. X to the third times x to the fifth would be x to the eighth. 3 plus 5 is 8 over 4, x to the sixth. Now, we've simplified the numerator using the product rule, but now we're going to need to refer back to the quotient rule, which says if you have like bases being divided, you're going to subtract their powers to simplify. So a to the m divided by a to the n would become a to the m minus n. Again, using the numerator minus the denominator. So when I look at this problem, 16 over 4, they're not like bases, but they're both numbers. So I can divide to just get 16 over 4 would be 4. And then x to the eighth divided by x to the sixth should give me x to the 8 minus 6, which is where the final answer of 4x to the second comes from, since 8 minus 6 would give me a 2. So the product rule, the power rule, and the quotient rule are all rules you've worked with before. So let's try one more question in our review of these rules. So now we have some different looking exponents. Actually, you know what, guys? I'm going a little bit too far. I'm going to make another video with these fractional exponents. So what we just reviewed in this video, the product rule, the power rule, and the quotient rule, we're going to stop there. And then please click on the next video to go through the rule of exponents dealing with fractional powers.